Good morning all. Here we are at the shop another day, and we're going to map this firing channel, the high side firing channel, so that we can test it. Now, once we get one of these mapped out, the others are going to follow suit. They're going to be the same, so we only have to map one firing channel. Right here is the PC928 optocoupler. This is a gate driver optocoupler. We're going to use that as our go-by to help us map this circuit out. Now, can I get everybody in the frame here? This is hard to draw and work at the same time, trying to stay in the camera. Set all this over here. Will that work? Where do I need to be? Right here. I want to kind of center this. Will that work? I think so. Let's see. Let's get straightened out here. Now, pin 12 of the optocoupler, or I'm sorry, pin 11 of the optocoupler is the output. Pin 14 and pin 10 are ground. Pin 13 are VCC. So we'll have to map that VCC and ground circuit up to find out how that IC is being powered, how it's being powered up. We know, and my meter's going to be off the frame here, but if I go from pin 4, which is the gate input to the IGBT, and pin 5, which is the emitter, I have 4.65 kilo ohms. So let's go back to beat mode. Let's draw that out. Oh, I'm reaching across the board, making a mess of my drawing. If only I could do this. Okay, let's draw pin 4. And there's pin 5. All right. Okay, I have continuity from pin 4 to this resistor, and it says 472. That's a 4.7 kilo ohm resistor. There's where our 4.7 kilo ohms is coming from. Let's draw a resistor in here, and that is 4.7 K. Let's get moved over a little bit here. Okay. Now, we know that pin 11 is our output, so let's go from pin 4 to pin 11. Here's 8, 9, 10, 11, and I have 75.4 ohms from the output of the optocoupler to pin 4. So there's 75 ohms. Pin 11. Let's see where pin 5 goes. Does pin 5 go to ground on the optocoupler? No, it does not. Does it go here? Yeah. Okay, there's a Zener diode. And let's see, that's the cathode side of the Zener. goes to pin 5. Let's see if the anode side of the zener goes to ground. Yes, it does. Okay, so we're going to draw a zener diode right here. And we're going to put a little VH, or V high side, right there, so we don't get confused with U high side and W high side. They're going to be separated. These grounds are not connected together on the high side. I'd like to see what the part number of that zener is. It looks like 5GB marking code. Looks like 5G or 56 on the first line and B on the second line. ZD21. That is ZD21. We're going to give it a label. Zener diode 21. And the 4.7 kilo ohm has a label on the board also, R24. So let's label that R24. Let's start drawing in our optocoupler. And for now, we're working on the output side. This is PC21. And its part number is PC928. Labeled according to the data sheet, out number 2. Out number 1 is on 12. Let's see where 12 goes. 8, 9, 10, 11, 12. Okay, 12 is tied to VCC. I'm going to move this down a little bit so you can see. Out 1, pin 12 is tied to VCC of that output side. And we don't know where 13 and 12 go yet. We're not there. And we might as well put the grounds in. The grounds are on 14 and 10. This is ground VH. We're labeling it VH. We don't know what Yaskawa labeled it as, but we're going to label it as VH. V high side firing channel. Okay, we've made quite a bit of progress. Oh, the 75 ohm resistor is on the back side, right here. Capacitor C22 that goes to 13 and 12. Okay, let's draw that in there. C22. Draw our ground. What did we miss? Let's go over here. Look at our drawing again. There's 14 and 10 is ground. 13 is VCC. 12 is out 1, that's tied to VCC. 11 is going to the gate of the high side V channel through a 75 ohm resistor. And 9 and 8 are called IGBT protector circuit. It's interesting. I'll have to read up on what that IGBT protector circuit does, what its function is. 8 is labeled FS and 9 is labeled C. Okay, let's see where VCC and ground are derived from. We have to power up this IC in this channel separately from these two high side firing channels. And the low side firing channels, the grounds are connected together. They don't need to be separated, but the high side does. So let's go see. There it is. This is that wire that goes to the power supply board. So there's 1, 2, 3, 4. Let's see where ground is. 5 is ground. Let's check the other ones. Here's 13. 3, 4, 5, 6, 7. 8 is ground. How about this one? There's 13. 1. That's on pin 1. And its ground is on pin 2. So this circuit is powered up from the power supply up on the top. And let's go ahead and write that in. 1, 2, 3, 4, 5. Get this out of the way here. We're going to bring our little connector in. So 4. We've got a little bit more. I got to have room for the ground. Yeah, we'll just come back even with this one. What a coincidence. 4 and 5 on the power connector to power up the PC928, and 4 and 5 going to the gate of the IGBT. Okay. That connector has a name, CN341. CN341. Let's go ahead and name this gate V high and emitter V high. We don't get these two confused. Okay, I don't see a connector name for the connection to the IGBT, so we'll just leave that blank. Now, let's go to the other side. The other side, four, 5, 6 and 7 are internally tied together, and they're labeled no connection. So 4, 5, 6, and 7 are no connection. Nothing gets connected to those pins. 1 and 2 are labeled anode and anode of the LED. And 3 is the cathode. So we will map out 1, 2, and 3. Let's look first. Let's get back in the picture here. Turn the board around. Now my guess is that it is going to go to one of these stake connectors over here on the input side. Let's go ahead and draw our input. We'll put it right here. Let me see if they're using the first 2 pins. Yes, they are connected. 1 and 2 are connected. Let's move that out of the way. There's our LED inside the PC928. Let's bring the cathode out. This is pin 1 and 2 on the anode side of the LED. And 3 is the cathode. Let's see where pin 3 goes to. 1, 2, 3. Goes to pin 3 over here on the stake connector. Okay. Now, 1 and 2 go to this resistor, R201, and it goes to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on the stake connector. Okay, let's move this out of the way. I see 221 on R201, and that is a 222 ohm resistor. Okay, let's move this out of the way. Let's write that in. 220 ohms. My meter said 222. Now I'm going to guess that pin 11 is common to all the other resistors. Let's see. Let's go back into beep mode. Yep. Yes. And yes. Okay, so this pin 11 goes to others. And this is pin 3 on the stake connector. To 5 each other resistors. Okay, what was that connector called? Stake connector CN322. Let's write that on there. Stake connector. This is a white connector. And this one is black. With no designated number. And we have enough information to power up that firing channel and test it. What we're going to do is this upside down. Let me get turned around so you guys ain't upside down. What we need to do is first figure out what VCC is. And we can pull that up from the data sheet. It'll tell us what voltage to apply. Positive on 4 and ground on 5 of the CN341 connector. Then we already have a 4.7 kilo ohm load across 4 and 5, so we don't have to place anything out here. We're going to look across pins 4 and 5 with our meter. As we apply a positive voltage to the common terminal 11 and drive 3 to ground from a separate power supply, not the same one as this one. We are isolated from the logic side to the power side. And the reason optocouplers are used is because we want that isolation. If we were driving that gate directly from, say for instance, a driver IC, a ULN 2003 or whatnot, or from an output of a microcontroller, when that IGBT failed, it would have shot back up into the logic circuit and destroyed it. And we'd have more troubles than just from here on out. Let's see if we can get this thing hooked up and tested. I'll put this drawing up at the end of the video so y'all can study it. Let's see what our VCC voltage is. Here's the forward current of the LED labeled IF. It is 25 milliamps, and that's absolute maximum rating, so we do not want to exceed 25 milliamps. I don't see VCC on this page. Well, here we are. Oh no, that's current detecting voltage. That's part of that IGBT protector circuit. That's different. We're going to have to go to a different page to find out what. Oh, here we are. Here we are. Here it is. Supply voltage. VCC. 35 volts, absolute max rating. We cannot exceed 35 volts to power up this chip on pins 14 ground and 13 VCC. We'll start out at 15 volts and see if when we drive the input we have output. Use this function generator to drive the input side of the optocoupler. We're going to send square wave of 5 volts peak into the LED side of that optocoupler. Now, we have to apply 5 volts to pin 11. That's the anode sides of the optocouplers through 220 ohms into each pin 1 and 2, the anode side of the optocoupler. So let's connect our clip lead. Get my close-up glasses on, and we're going to go to pin 11 with plus 5 volts. Here's ground. We're going to connect ground to the ground side of the function generator. And this is going to go to the cathode side of the optocouplers. Just put green here. Okay. Now we're going to test the V high side channel. And that is on pin 3 of this state connector. The input side, I mean. 1, 2, 3. Next thing we have to do is power up VCC and ground of that optocoupler's output side. And we're going to use this power supply over here set to 15 volts. I need to find me a ground for the 15 volt side. There we go. All right. We're going to have a spaghetti mess here in a little bit. The gray one. Okay. Ground of 15 volts that we're using goes to pin 5 of this state connector. 1, 2, 3, 4, 5. And VCC goes to 4 of this connector. Now we have all inputs connected, power supply connected. We need to turn the function generator off, power up the scope. Alright, we'll get closer to this as we go along. Let's see what happens. Okay. One, 2, 3, 4, and 5. Look at that, we've gone negative. Let's see if we have pulses. There they are. Look at that. We spread the time out a little bit. Bring the time back in. There's our gate firing pulses. Right there. That firing channel is good. Let's remove the pulses. We're at negative 4.49 volts. That's set by that Zener diode going to ground. Amazing. So the pulses go from negative 5, about negative 5, up to about 7, 8 volts peak. Let's get closer to that oscilloscope so you can see. Ain't those pulses pretty? That is very nice. Let's go check the U high side firing channel and make sure that they look like these pulses. We can compare the V high side to the U high side. I've got to move the clip leads around, so give me a little bit to get the U high side set up. Here we're pulsing the U high side optocoupler input. We're looking at its output on the U gate and emitter high side inputs to the IGBT. They look the same, don't they? So the U channel survived. Now I'll put up some drawings of the connections here so you can test your Yaskawa firing channels on the SGDB-20VD. Awesome. Awesome. Evening, oh, here we are at the house and it's dark outside. Did it get dark quick? Here we are at 6:43 and it seems like it's time to get up and go back to work. What we're going to do here first with this picture is we're going to look at some relevant connections based upon my drawings, so that when we look at my drawings you will know what we're talking about. Now over here, this connector, it supplies the DC voltages for the output side, high side firing channels. This connector over here, it supplies the low side firing channels. Now over here on pins 1 and 2, pin 1 is VCC U high side, pin 2 is ground U high side, 3 is no connection, 4 is VCC V high side, and 5 is ground V high side, 6 is no connection, 7 is VCC W high side, and ground W high side. Now those are the DC voltages that supply the output voltage for the PC 928 gate driver optocoupler. And when we test the high side, we are connecting a DC voltage of plus 15 volts to 1 and 2, 4 and 5, 7 and 8, and that powers up the output side of this gate circuit. Now this circuit right here, this black connector, sits on the gate pins of the IGBT. This is U high side, this is V high side, and this is W high side. And we have to move our DC voltage from the pin connectors right here to power up each circuit individually as we test it. So when we were testing U, or external 15 volts DC was attached to 1 with its ground attached to 2. Then we moved our external DC power supply to 4 and 5, and then our external DC power supply to 7 and 8. Now to check the low side, these three right here, and the braking optocoupler, we applied plus 15 volts to pin 1 here and its ground to pin 2. This connector on the board is labeled CN341, and this connector over here is labeled CN342. The stake connector right here is where the processor sends signals down to the input of these gate firing optocouplers. The stake connector is labeled CN322, and over here is pin 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There's 12 pins on that connector. Pin 11 through the 220 ohm resistors goes to the anode side of the input LED on these optocouplers. So I attached 5 volts DC from an external power supply to pin 11. Pin 1 and 2, 3, 4, 5, 6 are for the inputs of the optocouplers on the cathode side for the UVW high side and low side gate firing optocouplers. Pin 7 is for the brake optocoupler. So with 5 volts applied to pin 11 through a function generator set to a square wave of 5 volts peak to ground, I was able to pulse that input side LED. And thus, when that was being pulsed and the output side was powered up, we had pulses to the IGBT gate connectors. Now let's back up a little bit, and on the IGBT connector, the gates connect to this connector right here. The pins of the IGBT gates come up through these sockets. And so here are 3 pins, 1, 2, and 3, 4, 5, and 6 on the next set, 7, 8, and 9, and then 10, 11, 12, 13, 14, 15, and 16. Is that everything on the board? I think it is. I think we've covered everything on the board. So let's go look at our drawings. Here is the firing channel for the IGBT gate and emitter on the V high side. Here's our PC928 gate driver optocoupler. Here's the input to the anode of the LED inside that optocoupler, and here's the cathode. Now, pin 11 is common to all 7 anodes of the optocouplers. Pin 3 shows the input from the stake connector, CN322. So we applied 5 volts to pin 11 from an external power supply. Pin 3 was derived from a function generator, and the function generator provided the square wave from 0 to 5 volts to turn this LED inside this optocoupler on and off. The ground side of the external power supply was connected to the ground of the function generator. Up here, CN341 on pins 4 and 5, I applied 15 volts up here to 4 from an external power supply and ground from that external power supply to pin 5, and that powered up the output side of this PC928 gate driver optocoupler. The output of the optocoupler was connected to pin 4 through a 75 ohm resistor. Pin 5 of this connector right here that connects the firing board to the IGBTs through this connector was connected to ground on V high side through this 5 volt Zener diode. The grounds of the PC928 are 14 and 10, and they're connected to this point right up here and here on the V high side ground. Amazing. That is amazing. Now let's look at the connectors. CN341, CN342 that connect the VCC and ground to the PC928s, and we'll look at the state connector CN322, and we'll look at the pins that drive into the different PC928 optocouplers. Here's CN341, and it provides a connection from the DC power supply up top to the high side firing channels on the output side of the PC928. Pin 13 being VCC and 10 and 14 being ground on that optocoupler. So on pin 1 and 2, when you want to test the U high side firing pulses, you have to power up that PC928 by applying 15 volts to pin 1 and its ground to pin 2 from an external power supply. Down here, V high side and ground high side, VCC and ground of the V high side are on 4 and 5. So when you're done testing this U high side firing channel, move that power supply to 4 and 5 to test the V high side firing channel. When you want to test the W high side channel, move from 4 and 5 to 7 and 8. 7 being VCC, W high side, and 8 being ground on the W high side firing channel. Now the low side, you only have to connect once to CN342, CN342. Pin 1 is VCC for the low U side, low V side, and low W side. Pin 2 is ground on the low U side, low V side, and low W side. So you only have to connect once to test those 3 firing channels. The stake connector, labeled CN322, is the input to the firing channels on the LED side of the optocouplers from the processor. Pin 11 again, we apply plus 5 volts DC, and that supplies our voltage to the anode side LED of the optocouplers in the firing channels, plus 5 volts DC up here. To test the U high side, we apply the function generator pulses to pin 1, with the ground of the function generator referenced back to this external 5 volts DC power supply. For the V high side end, that was the firing channel that we were concerned with because the V was shorted to plus bus and the gate and emitter was shorted also. So we especially wanted to check V high side, and we put the function generator on pin 3. Now remember, you have to move these DC voltages over here to test these individual firing channels. Pin 5 is W high side, input to that optocoupler. Now here we have the low side, U low side in to the optocoupler is on 2, V low side in is on 4, W low side in is on 6, and the break in is on 7. Now we have PC11, PC21, PC31, PC41, PC51, PC61, and PC71. That is the designation for these optocouplers, the designation on the board. Is that everything? Did I miss something? Were you able to see this in the dark? Oh, when winter gets to coming around here, we go into the dark real quick. Well, I got into the backyard before the sun went down and was able to fill up the bird feeders and make sure the critters back there was doing alright. So if I missed something, let me know. Or if something was a little bit confusing, let me know down in there in the comments, and I'll try to clarify if I can. That was a lot of fun drawing out that circuit. Doggone it. Where's my mind? I forgot. Did I? I must have. Yes, I did. Sorry. Panic attack. I did show you the circuit for the V high side firing channel. Losing my mind here. Okay. Well, I hope y'all's doing alright out there. We get to get up and go back for another day's worth of work tomorrow. Our days don't end, do they? Alright, all. Again, I hope you enjoyed that video, and next time you get your Yaskawa SGDB-20VD, you'll be able to test your firing channels. Good night, all. We'll see you when the sun comes up.